Hello viewers, welcome to JSM. In previous video, I have explained the effect of hydrogen bonding on physical properties. So that is first one, solubility completed. So in this video, same, that is effect of hydrogen bonding on physical properties. In that second one is what? Boiling point and melting point. So on boiling point and melting point, how hydrogen bond is affecting on boiling and melting points of the different compounds. First, boiling point and melting point. Boiling point and melting point. Okay, we know. So boiling point and melting point. So in general, so for what we are explaining boiling point, for liquids we are explaining boiling point. So melting point is what? Melting point. For the solids we are explaining melting point. Okay, so now here in this effect of hydrogen bonding on physical properties, so boiling point and melting point. So now for our convenience, so this is the boiling point, I am writing as BP, and melting point I am writing as MP, that is melting point, is directly proportional to intermolecular hydrogen bond. So intermolecular hydrogen bond means what? That is extent of hydrogen bonding and strength of hydrogen bonding. Based on that we are explaining boiling and melting point of the different compounds. Let us take one example, that is water molecule and hydrogen sulfide. So that is H2O and hydrogen sulfide. So now in this water molecule, the extent of hydrogen bonding is more, so compulsory its boiling point is more. So whereas in case of hydrogen sulfide, so it cannot form hydrogen bond. So now the boiling point of water molecule is greater than hydrogen sulfide. Okay, so based on the extent of hydrogen bonding in molecules, we are explaining what? Boiling point. So now here, to find boiling point or to check boiling point in different molecules. So compulsory here it is the to check boiling point of different molecules, compulsory we have to follow what? First one is hydrogen bonding and second one is what? Van der Waals forces. Based on that we are explaining boiling point of different compounds. So that is to check boiling point of different compounds. So compulsory we have to know what is that? Hydrogen bonding and Van der Waals forces. This is VWF, right? This is what? Van der Waals forces. So this is Van der Waals forces. Okay, na? So based on hydrogen bonding and Van der Waals forces present in different compounds, so we are explaining what? Boiling point of different compounds. For example, 15th group hydrides I am taking. 15th group hydrides, that is hydrides of 15th group. Okay, hydrides of 15th group, we know that what is that? First one is ammonia, second one is phosphine, ASH3, SbH3. So these are hydrides of fifth group, 15th group elements or fifth group elements. Okay. So ammonia, right? This is phosphine, this is arsenine, this is stibine. Okay. So now in this boiling point order. So now here it is what? This is the nitrogen. This is the nitrogen. So now it is capable to form what? Hydrogen bond. Hydrogen bond. So whereas in case of this remaining three hydrates of 15th group, they cannot form hydrogen bond, but they can show what? They can show what? Van der Waals forces. Okay, they can show what? Van der Waals forces. Van der Waals forces. So now ultimately here it is what? Boiling point order. So order of boiling point is what? Here it is what? First one, hydrogen bond. So that NH3 is greater than. Okay, na? So first one we have to check what? Hydrogen bonding. After that we are seeing what? Van der Waals force. Van der Waals force of attraction. So right here it is what? So now here in the remaining these three. So now they are in a group from top to bottom, or moving downwards in a group. Moving downwards in a group, we know that atomic size increases, molecular mass also increases. So compulsory van der Waals force of attractions also increases. So now here it is second one is what? SbH3 greater than ASH3 greater than pH3. So this is the boiling point order, or order of boiling point of what? 15th group elements. 15th group elements. Okay. So now this is the order based on what? This is hydrogen bonding and van der Waals force of attractions, right? It is expected order. So this is what? Expected order. Okay. So this is expected order. So what is actual order? So the actual order is based on what? Here it is one experimental phenomena is there. So that is the beauty of what? This is ammonia. That is the flipping of ammonia takes place. Flipping of ammonia takes place. So due to that, so whatever order I wrote, so this is only expected order. So write complete, it is different from what? Actual order. So now this is the phenomena taking place in ammonia in liquid state only. We know that the structure of ammonia, is we know that nitrogen. So right, it has one lone pair, and first hydrogen, second hydrogen, third hydrogen. So now flipping. So what is the meaning of flipping? So this is around the plane, the rotation of this molecule around the plane. Okay. So now here it is what? It is a lone pair, and we have out here we have what? Hydrogens, right? Flipping means what? So like this around the plane, it is almost all 180 degrees. Almost all 180 degrees of the moving. Okay, around the plane. Around the plane. So now for example, if it is this is the plane. If this is the plane of this molecule, so around this plane flipping takes place. So right after flipping of this ammonia, right? So what is happening here? It is what? Flipping. Okay. So right, what is this? Flipping. So after flipping, so here it is what? Same nitrogen. Here we have what? Lone pair and 3 hydrogens. 3 hydrogens. So now after flipping, complete around the plane, so almost all rotation around the plane. So like this takes place. So this process of this phenomena is known as what? Flipping. So right, in liquid state only, this flipping is possible. Okay. So now here you see. So now here it is the normal state. So now this is the lone pair is capable to form hydrogen bond. Yes. So now these are hydrogens also capable to form hydrogen bonds. So once it is flipping, so what happens here? This is the, for example, it is the stable position of this lone pair. Stable position of this lone pair is present. So now whatever bond is formed, it is also stable. But in next fraction of seconds, so like this flipping is takes place. So now whatever bond formed by this lone pair, so that is the hydrogen bond. Hydrogen bond is not stable. So due to that, what happening? So now here it is the extent of hydrogen bond is decreasing. Where? So in case of flipping. So now if it is the stable position, formed bond is also stable, but in fraction of seconds like this flipping is taking place. So what happening here? So now whatever bond is forming by this lone pair of electrons or hydrogens, so right, they are not stable. They are not stable. So due to that, what happening? So the extent of hydrogen bonding decreases in ammonia. In ammonia due to flipping. Due to flipping. So now here it is, for example. So first point I am writing, in liquid state only flipping takes place. Okay, so right. Due to flipping, the extent of hydrogen bonding, decreases. Okay, na? The extent of hydrogen bonding decreases. Okay, so now, so here this is what ammonia. Here it is what hydrogen bond, that is extent of hydrogen bond is decreases. We know that this is the expected order. This is what that is expected order. So now what is actual order? So now the actual order of this is what? So now here it is according to this. So which one having more boiling point? Ammonia. But after explanation of flipping in ammonia, what happening? So now this is the ammonia is decreasing, the extent of hydrogen bond is decreasing due to flipping. So now you tell. So now what is this? Here it is the order of boiling point. So now it is so first it is what? SbH3 greater than NH3 greater than AsH3 greater than PH3. Okay, so this is the actual order of boiling point. Okay, so this is what actual order of boiling point. Okay, so now here it is what? Ammonia in liquid state only, it takes place what? Flipping. So it is involving in flipping. So that's why it's extent of hydrogen bonding decreases. So that's why it is. So now in SbH3, so which one is dominating? Here it is in SbH3, van der Waals forces are dominating. So this is the actual order of boiling point of 15th group elements. So in water molecule, flipping is not possible. Because in water molecule bond angle is less and hydrogens are, so they are far away from plane. So now here I am comparing ammonia and water molecule. So now in case of ammonia, we know that lone pair and 3 hydrogens are there. So in case of water molecule, so now here it is the hydrogen. So first lone pair, second lone pair. So now here in case of ammonia, say for example this is the plane, and here also in case of water molecule this is the plane. So now here between these two here distance is less that is distance is less, they can easily flipping takes place, because here distance is less, here it is the bond angle is nearly, it is 107 degrees. Bond angle is nearly 107 degrees. So now here to this plane, these are the hydrogen atoms are very near, and it is a flipping, it is easily takes place. Flipping easily takes place. But whereas in case of water molecule, here bond angle between these two hydrogens, it is 104.5 degrees. 104.5 degrees, and the distance between this hydrogen and this plane, here it is the distance is more. Distance is more, so that in case of water molecule, there is no flipping takes place. So flipping it requires more amount of energy. So now in case of ammonia, flipping is easily taking place, because here it is the distance is very less, so they can easily flipping. But in case of water molecule, here bond angle is less. When compared to this bond angle, here it is somewhat more, so that's why it is very nearer to plane. Here it is the distance is more and the bond angle is very less. Due to this, in case of water molecule, flipping is not possible. Comparison of boiling and melting points of different groups. So first one, hydrides of 15th group elements. So first one is what? Boiling point. Order of boiling point. So already I have explained, right? Here it is boiling point order is SbH3 greater than NH3 greater than AsH3 greater than PH3. So now this is the order of boiling point. Okay. So next one, melting point. Order of melting point. So now here it is what? NH3 greater than SbH3 greater than AsH3 greater than PH3. So already I have explained boiling point. We know that in case of liquid we are explaining boiling point, in case of solid we are explaining what? Melting point. So now in liquid state, flipping of ammonia taking place. So now here it is what? In case of SbH3, which one? Van der Waals forces are dominating. So now in case of melting point, so now where it is ammonia in solid state, so now the extent of hydrogen bonding as it is, that is what? 4. It can form 4 hydrogen bond. So now its melting point is more. So remaining is what? Remaining SbH3 is greater than AsH3 is greater than PH3. So now here it is what? Van der Waals. Okay, na? Van der Waals forces. So now here it is what? Hydrogen bond. So now hydrides of 16th group elements. So hydrides H2O, H2S, H2SE, H2PE. Okay, so these are hydrides of 16th group elements. So now here it is what? First one is what? Boiling point. So right, in case of water, we know that extent of hydrogen bond is more, so compulsory it having more. Boiling point H2O greater than. So now in case of remaining 3, there is no formation of hydrogen bond. So which one are dominating? So here Van der Waals forces are dominating. So now here it is what? H2TE greater than H2SE greater than H2S. So this is a order of boiling point. So next one is what? The melting point. Here it is a melting point. Okay. So now here it is hydrides of 16th group. Here it is extent of hydrogen bonding in water is more, so compulsory water also having what? More melting point, so that is H2O greater than, so remaining order is same here, so that is H2Te greater than H2Se greater than H2S. Okay, so these are the order of melting and boiling points of hydrates of 16th group elements. So now hydrates of 17th group elements, so they are hydrogen fluoride, hydrogen chloride, hydrogen bromide and hydrogen iodide. Okay, so now here first one is what? Boiling point. So now here it is what? The extent of hydrogen bonding in HF is more, so compulsory hydrogen bonding in HF is more, so first boiling point is also more in hydrogen fluoride. So in remaining these three hydrates of 17th group elements, so that is the extent of hydrogen bonding is less, and which one are dominating? Van der Waals forces are dominating, so that's why hydrogen iodide greater than hydrogen bromide greater than hydrogen chloride. Okay, so right, now here it is a melting point. We know that where in case of solid only we are explaining what? Melting point. So now here it is the liquid state. In liquid state, hydrogen bond, the extent of hydrogen bond is actually it is what? 2, but what we are expecting? We are expecting 4. Where in case of this hydrogen fluoride 1 2 3, so 1 2 3 lone pairs are there, but due to small size of fluorine, these two are not involving in the formation of hydrogen bond, so only one is involving. But where in case of solid, here it is these two lone pairs are not involving in the formation of hydrogen bonding, they causes repulsions. Okay, so now the order of melting point is what? As usual, it is hydrogen iodide is greater than hydrogen fluoride is greater than HBr is greater than HCl. So now this is what? Melting point, order of melting point. This is order of boiling point of what? Hydrates of 17th group elements. So now these are the 15th group, 16th group and 17th group. So now here it is a comparison between different compounds. So first one I am taking hydrogen fluoride, second one is what? Water, and third one is what? Ammonia. So now in these three compounds, so now first one is what? Order of boiling point. Okay, na? We know that. So here the extent of hydrogen bonding is water molecule is more, right? That is H2O is greater than. So now you compare hydrogen fluoride and ammonia. Here boiling point means what? Liquid state. In liquid state, flipping of ammonia takes place. So the extent of hydrogen bond is less in ammonia when compared to hydrogen fluoride. So now here it is H2O is greater than HF is greater than ammonia. So this is what? Boiling point. So now here it is, next one is what? Melting point. So write the melting point regarding solid. Yes, here also same. Flipping is not possible in water. Again it is having more melting point. Water is greater than. Right. Now in comparing between these two, hydrogen fluoride and ammonia, in solid state, in ammonia also flipping is not possible. Flipping is not possible. So now, whereas in case of this, the extent of hydrogen bonding is 4, but here in case of this, extent of hydrogen bonding is only 2. Only 2. So that's why here it is the H2O is greater than ammonia is greater than hydrogen fluoride. Hydrogen fluoride. So this is in different compounds.